Hello friends, welcome to Learner's Planet. Friends, this is our geometry workshop, and in these sessions we are discussing trapezium. This is the second part for trapezium. In the previous session we discussed the basic properties. We discussed some of the problems based on trapezium, and all the problems that we discussed in the previous session were from the previous year CAT papers. And you might have observed that if you are conceptually clear, it's really easy to crack the problems in even a very limited duration of time, right? So in this session we are going to take some more concepts related to trapezium, some more facts we are going to discuss. Okay, just have your paper and pen with you, note down the concepts that I'm discussing over here and do revise them once again. Okay, so let's begin. Now suppose we are going to discuss the next concept. Here suppose the trapezium ABCD is there. Length of the parallel sides is X and Y. And this is the, you can say this is P and Q. PQ is, P is the midpoint of side AD and Q is the midpoint of side CB, right? So PQ is parallel to AP and CD, both of them. Now the important thing that you should be knowing over here, since PQ is the middle line between CD and AB, it's not necessary and it will not be a fact that area of PDCQ will be equal to APQB. But obvious, right? You can see the difference as well, right? So do not get confused. Here what I'm trying to do, I'm trying to find out the length of PQ if I'm having the length of X and Y, right? Now just listen to me carefully. I'll be dropping, just wait for a moment. I just draw a line parallel to CB over here. That's this. Okay. So length of this complete is X. This length is Y. So this length must be X minus Y. And I assume this point to be PQ. Suppose this is R. Right? Now, and this is suppose S. You must be knowing the midpoint theorem. Now what exactly midpoint theorem is? See, P is the midpoint of AD, S is the midpoint of DR, and PS is parallel to AR. That means length of PS must be half of AR, right? Listen to me once again. According to midpoint theorem, if P is the midpoint of side AD and if it is joined to the midpoint of other side, then this length is half of the length of the third side, right? So this length, whatever is this length, that means PS will be half of AR. Okay? Okay. Now what? So that means this length is what? Half of X minus Y. This complete length we assume to be X, and this we have drawn a parallelogram. So the sides will be equal. This is Y, and this will also be Y, right? So this length AR will be, from this entire we deducted this, that means X minus Y. That means PS is what? Half of X minus Y, right? So this length is half of X minus Y and this length is Y. So PQ will be X by 2 minus Y by 2 plus Y, right? So it's X by 2 plus Y by 2, right? Y minus Y by 2, you'll be getting Y by 2. So it is X plus Y by 2. So that's an important derivation, right? If PQ is the middle line, then its length will be, you can say, arithmetic mean of the length of the sum of the, or we can say length of the parallel sides, right? That means this length is X, this length is Y, then PQ will be X plus Y by 2, right? This concept will be used various times, so be careful about it. The only condition is PQ must be, P must be the middle point of or center point of AD and Q must be this. That means PQ must be middle line. Okay, so length of this will be given by X plus Y by 2. Okay, it's an important concept. Now friends, various concepts related to trapezium we have discussed, right? Now we take some problems based on trapezium. So while applying the concepts, the concepts will be cleared in your mind and you'll be able to solve the problems. Okay, so just get ready with your paper and pen. Try to solve the problems on your own and then match your answer and solution with mine. So let's begin. Now we have this question. Here ABCD is a trapezium and PQ is the midline. That means P and Q are the midpoints of side AD and BC respectively, right? Length of PQ is given as 10. Area of PQCD, that means the midline divides the trapezium into two parts and the ratio of their areas is 3:5. We have to find out the length of these two sides, that's two parallel sides, right? Now what I do, I assume this to be x, this to be y, and this is already 10 that we know, right? Now as we have already discussed, the midline is actually arithmetic mean of lengths of parallel sides, right? So x plus y by 2 is equal to 10, right? That means x plus y will be 20. That means sum of the lengths must be 20. Okay. Now what? Suppose this altitude is actually h, right? So the upper portion will be h by 2 and the lower portion will also be h by 2, right? You can assume it to be 2h or maybe h. If you assume it to be 2h, take this h and h, right? So the upper portion is h and the lower portion is also h because this is the midline. Okay. Now what? The area of this triangle, this trapezium, this is also a trapezium, PDCQ. So area of this trapezium will be what? Sum of parallel sides into distance between them and half, right? So that's 10 plus x, sum of parallel sides into distance between them by 2, right? Similarly, area of this APQB will be sum of parallel side, that is y plus 10 into distance between them, that's h by 2, right? And that's actually 3:5, right? Now we got 50 plus 5x is equal to 30 plus 3y, right? So 5x minus 3y plus 20 is equal to 0. And if we multiply this equation by 3, we'll be getting 3x plus 3y minus 60 is equal to 0, right? So if I add these two, I'll be getting 8x is equal to 40, that means x is equal to 5. So if x is 5, y must be 15. So this length is 5 and this length must be 15. Okay, so very easy to solve once you are conceptually clear. Okay, let's take the next one. Now in this problem, we have trapezium A, B, C and D, right? The length of the bases is 5 and 15 and the diagonals are 12 and 16, right? Now we have to find out the area of this trapezoid. Now friends, here we are having this problem. ABCD is a trapezium. The length of the diagonals is given as 12 and 16. The parallel sides are 5 and 15. We have to find out the area of this trapezium, right? Now, I suppose this intersection point to be O, right? Now, DOC and AOB are similar triangles, obviously. So that all the sides will be in proportion. If this side is to this side is 1:3, that means this ratio to this ratio, that should also be into 1:3, and this is to this, so should also be into 1:3, right? Now if as this entire length is 12, that means this must be 3 and this portion must be 9, right? 1:3 ratio. Similarly, if this entire length is 16, then we have to break it into 1:3 ratio. So that's 4 and 12, right? Now what? You can see 3, 4, 5, these are Pythagorean triplet, and similarly 9, 12 and 15, they are also Pythagorean triplet. That means this angle is 90 degree and this angle is 90 degree, right? Now what I do, I drop a perpendicular over here. That's y and similarly that's x. right? Now listen to me carefully. I take triangle ODC, area of this will be half of 4 into 3, that's 6, right? Similarly, that will be equal to half of OX into 5, that is altitude into base. So that is half of base into altitude. So that's OX, right? So OX is what? 36 by 5. I'm sorry, 12 by 5. Okay. Similarly, we can calculate OY. So that's 12 into 9. Half of 12 into 9, or we can say 6 into 9. So that's 54 is equal to half of 15 into OY. Right? So OY will be equal to 36 by 5. Right? Now we got OX, we got OY. So we got the entire length XY, that is the altitude of this trapezium. So that's 48 by 5, right? Now we can easily find out the area, that is half sum of parallel sides, that's 15 plus 5, 20, into distance between them or altitude, that's 48 by 5, right? So that's 96 units. Okay, so quite easy problem. This much work only you have to do, right? Now we have this question. This question involves concepts also, so just watch carefully. The lengths of the bases of trapezium is 16 and 12. So this is 16 and this is 12. Find the lengths of the line segment joining the midpoints of the diagonal. Maybe the midpoint of this diagonal is this and the midpoint of this diagonal is this, right? So we have to find out this length. I suppose is to be PQ, or maybe the length is L, right? It is A, B, C, D, and this is O, right? So we have to find L. Now what, friends? We have discussed so many times that this triangle ODC is similar to triangle AOP. That means their sides will be in proportion, right? Now the ratio of these two is 12 is to 16, or we can say 3 is to 4. That means this portion and this portion will also maintain the same ratio, and this portion and this portion will also maintain the same ratio, right? So I assume this to be 3, say x, and this will be 4x, right? The ratio should be 3 is to 4, but constant will be different, that you should be careful. And similarly this ratio will also be same, so that's 3y and 4y. Again the constant will be different because length of this diagonal may be differ from length of this diagonal, right? So the ratio of this is to this is 3 is to 4, this and this is to is 3 is to 4, right? Now we have to find out this length, right? That's actually what? The midpoint of this diagonal, and this is actually midpoint of this diagonal. Okay, this is the intersection point, right? Now here I'll be using the cosine formula. Cosine formula, why? Because this angle will be equal to this angle, isn't it? So whatever is this angle, maybe it is alpha. So cos alpha will be what? I'll be using cosine formulas. This square plus this square minus this square, right? See, cosine formula, cos alpha is equal to this square, that's 9x square, plus this square, that's 9y square, minus this, that's 144 square, right? By this 2 times this into this, 2 times 3y into 3x, right? And this is also alpha. So again I'm taking cos alpha for this triangle OPQ. I deleted cos alpha because the cos alpha will be same. So here in this case, this length, see this complete length is what? 4x, right? And from this point to this point, it is the midpoint. So this length will be 7x by 2, right? This to this, or we can say this to this, that is 7x by 2, and this length is 4x, right? 7x by 2 is 3.5x. So if this is 4x, this is 3.5, that means this is 0.5, right? Or I can say x by 2. So that's x square by 4 plus, similarly this will be from this point to this point, it will be y square by 4 minus L square. So I write 4L square by 4. So I get a symmetry by 2 x by 2 into y by 2. Right? This 2 is cancelled. xy is cancelled. This 4 and this 4 is cancelled. Then this 3 3s are 9. Here I am getting x square plus y square minus 4L square is equal to, if I divide this entire expression by 9, I'll be getting x square plus y square minus 144 by 9, that's 16, right? So 4L square is 16, that means L square is 4, that means L is equal to 2, right? So you can use this as a formula also. The distance between the midpoints of the diagonal is what? This minus this by 2, right? 16 minus 12 by 2. And I have done the derivation also for you, right? You can do this way, or you can put up the formula directly, right? If the lengths of the trapezium are given to you as A and B, then it will be A minus B by 2, right? Whatever is the bigger length, I'm just writing down the magnitude over here. That's A minus B by 2. That is the length between, or we can say the length of the line segment that is joining the midpoints of the diagonals, right? Length of the line segment that is joining the midpoint of the diagonal. And how we have calculated that I have shown you over here, right? I hope you are clear. Now, one of the bases of the trapezoid serves as the diameter of the circle of radius 8 centimeter, and the other bases intercept an arc of 120 degree on the circle. Find the area of the trapezium. This is center of the circle. This is radius, must be 8. This should be 8. This should be 8. This angle must be 120 degree, right? Now after that, since this trapezium is inscribed in the circle, that means it has to be isosceles. That means this length must be equal to this length, right? And this angle must be 30 degree and this angle must be 30 degree. Now these two triangles are same, right? So if I find out the area of this, I can double to find out the area of this plus this, right? To find out the area of this triangle, I can use sine formula, right? That's easy. So what the area will be of this triangle? That's half 8 into 8 product of the sides into sine of included angle, that is sine 30 degree. So sine 30 degree is actually half, right? So area of this triangle is 16. Similarly, area of this triangle will also be 16, right? So 16 plus 16. Now see here. Here we will be using sine 120 degree. Sine 120 degree is cos 30 degree. So I just write half into 8 into 8 into root 3 by 2. So that's 16 root 3, right? So 16 plus 16 plus 16 root 3, that will be the area of this trapezium. This plus this plus this, right? So I can take 16 as common, 1 plus 1 plus root 3, or 2 plus root 3 into 16, that will be the area of this trapezium. Okay, so we have used up the concept of trapezium as well as the sine formula to find out the area of a triangle. Okay, I hope you are clear. Now friends, we have this question. A circle can be inscribed in this given trapezium ABCD. Length of AD and BC are given as 6 and 10. We have to find out the lengths of the parallel sides, right? And it is given that P is the midpoint and Q is the midpoint. That means actually PQ is the middle line. Now, we have to find out the length of AB and CD. Now concept that we will be using over here is, see this trapezium, a circle can be inscribed in it. That means that is possible only when the sum of non-parallel sides is equal to sum of parallel sides, right? Then only a circle can be inscribed into this trapezium, right? So precisely you got the sum of AB and CD, right? Suppose this is X, this is Y, then you got X plus Y is 16, that is 10 plus 6. So precisely we want the breakup of 16, okay? Now this middle line, as I've already told you, this middle line is what? Arithmetic mean of this and this. So the length of the middle line is what? 16 by 2. We can say 8. Okay. Now this height, I assume it to be h, and this height is also h. This perpendicular distance is h, and this is also h. Right. Now what I do? I find out the area of this trapezium and then area of this trapezium. Sorry, friends, forgot to mention one thing. Area of PDCQ and APQB as given as 5 by 11. Right? Forgot to mention PQCD by APQB is 5 by 11 area. That's given, right? This we have found out. Now what I'll do, I'll find out the area of this portion. What that will be? Sum of parallel sides into distance between them by 2, right? Then sum of parallel sides into distance between them. This entire distance is 2h, but since this is the middle line, this distance will be equal to this distance, right? And this by 2, both of them will be cancelled, and this is actually 5 by 11, right? So 11y plus 88 is equal to 5x plus 40. So 5x minus 11y is equal to 88 minus 40, or I can say 48. And x plus y is given to us as 16, right? So what I do, it's 11x plus 11y is equal to 176, right? So this is cancelled. 16x is equal to this plus this. That means x is equal to 48 by 16 plus 176 by 16, that is 11. So x is 14 and y is 2. Right? So this way we can calculate the lengths of parallel sides. A very simple concept we have used. We have found out the area of this, and equated with the given ratio. Right? Till here it's already given. This we have found out. How did we find it out? A circle can be inscribed in this trapezium. So in that case, sum of parallel sides should be equal to non-parallel sides, right? Middle line, we already know that is half of this. So that's 8. After that, it's very easy. Okay, I hope you are clear. Now this question, the length of the middle line of the isosceles trapezium is 5. It is known that a circle can be inscribed into it. The midline divides the trapezium into two parts whose areas are related as 7:13. The same figure that we have used earlier can be used over here. In this case, the length of the midline is 5, and the circle, this trapezium can inscribe a circle. That means sum of parallel sides should be equal to sum of non-parallel sides, right? Now, we know the length of the midline. That means length of the parallel sides will be what? Double than that of this. That means x plus y. Suppose the length of the parallel sides is x and y. So x plus y will be double of this. That's 10. Right? So that's 10. That means sum of parallel sides is 10. Now the same funda we are going to use over here. That's half. Then sum of parallel sides into distance between them. For them, assuming this distance to be h, so that's right? I draw a simple diagram over here. So this x plus 5 into distance between them is h by 2, and then y plus 5 into h by 2 is equal to 7 by 13. So 13 into x plus 65 is equal to 7y plus 35. So 13x minus 7y, or I can say 7y minus 13x is equal to 65 minus 35, that's 30, right? And here x plus y is 10. So I take 7y plus 7x is equal to 70. So that's 13 and 7, 20x is equal to 40. That means x is equal to 2, y is equal to 8, right? X is equal to 2, y is equal to 8. Now, so in this case, since it is an isosceles trapezium and it can be inscribed, a circle can inscribed into it. That means sum of the parallel sides should not be, should be equal to sum of parallel sides. That means this length plus this length must be 10, right? And since it is isosceles, that means this length and this length should be equal. That means it is 5, right? So what is exactly happening? Just see here. We have to find out this h, right? I just draw it over here. This is 5. This length from here to here, it will be 2 because x is 2. So from this point to this point it is 2. So from this point to this point it is 2. The entire length from this point to this point is 8, and these two portions will be equal. So if this is 2, this plus this must be 6, and these two are also equal, so it must be 3. So we have 3, 4, 5 Pythagorean triplet. That means height of this altitude, or we can say height of this trapezium, or length of the altitude must be 4. Okay, an interesting problem. Various concepts we have used in this solving the problem. Okay, I hope you are clear. Now friends, here we are having this problem. Here we are having a trapezium ABCD, isosceles trapezium. The parallel sides are given to us as 10 and 26. AC is perpendicular to BC, and BD is perpendicular to AD, and their intersection point is O, and we have to find out the area of this trapezium. Now, a similar problem we have already discussed. What I can do over here is I will drop a perpendicular from this to this, right? Now what is the length of this perpendicular? That I assume it to be h, right? The other thing, I drop one more perpendicular from this point to this point, right? Further, the length of this is also h, obviously. Now length from this point to this point is 10. The entire length is 26 and it is an isosceles trapezium. So this length will be equal to this length, right? So this part is 10. So the remaining part is 16. So it will be 8 and it will be 8. Okay. I assume this to be x. Now we have one relationship, that is x square is equal to 8 square plus h square. This is the relationship that we have. After that, see triangle ACB and this triangle, suppose it is CP, CPB will be similar to each other. As I've already told you, if you have a right angle and from this right angle, if you drop a perpendicular to the hypotenuse, then the two triangles and the origin, all of them are similar to each other, right? That means triangle ACB and triangle CPB are similar to each other. If they are similar, their sides must be in proportion, right? So I write the sides in proportion. I assume this to be D1, this AC, right? Now what angle opposite to 90 degree in this bigger triangle will be the entire length, that is 26. side opposite to 90 degree in this will be x, right? Side opposite to this common angle in this big triangle is D1. Side opposite to this common angle in this small triangle is H. And the third side is, say this is 26, this is 20 D1, and the third side is X. In this case it is X, H, and the third side is 8. Now what? X square is equal to 26 into 8. Right? Minus 64, that is H square. So 26 into 8 minus 64, you will be getting 144. So H will be 12. So this is 12. Now it's very easy to find out the area since you have got the distance between these two. Half distance between these two into sum of parallel sides. So that's 26 plus 10, 36. Right? So that's 6 cube, or we can say 216 units. Whatever, centimeter cube or whatever, right? So it's very easy to solve once you know the concept of similarity. I hope you're clear. Now let's try this problem. Find a trapezium MNQ. Find a trapezium MNQ PQ with bases NQ and NP. The straight line which is parallel to the basis cuts the legs, a leg MNN at point A, and this area of both the parts is given. Find AB if NP is equal to 4 and MQ is equal to 6. I draw the diagram. Now this is the diagram for this trapezium. This length 4, this length 6. AB, it is not midline, and it distributes this trapezium into two parts having the ratio, area in the ratio 2:7. We have to find out the length of AB. Okay. Now let's see how to solve this. In this particular problem, what I'll be doing, I'll be extending the sides MN and PQ, right? And I'll be forming a triangle this way. Okay. Now, why I'm doing this, you just get to know right now, right away. So this length is 4. I assume this length to be x, that we have to find out, right? Now what? See this triangle, this triangle, this triangle, and this triangle. All of the three triangles are similar to each other, right? And we are given the ratio of R1 is to R2. So area of R1 will be what? This entire triangle's area minus area of this, right? In case when the triangles are similar, their areas are in the ratio of square of their sides, right? So area of, suppose this is, say maybe y, right? So area of y and p will be 4x square, that means 4x whole square, that's 16x square, right? Area of this YAB will be x square in the proportion to their side, so that's x square, right? I just can choose a constant, or I can say that is kx square, right? So area of YAB is kx square, area of y and p is 16k, right? Okay, so if I have this area, if I deduct this area, I'll be getting the area of A and PB. So this is the area of A and PB, isn't it? Divide by area of this complete triangle will be in proportion to this square of this side. So that's 36k minus area of this triangle, that is in proportion to this side, a square, square of this side. So that's kx square, right? And this ratio is given to us as 2:7, right? So I can take k as common and can eliminate that. So if I solve, I'll be getting 7x square and minus 2x square, so it's that 9x square is equal to then 36 into 2, 72, and plus 16 into 7, right? So what I want x, so x square is equal to 72 plus 16 into 7, so that's 16 into 7, 112 plus 72, 184 by 9, right? Now this is 184, 4 can be taken as common, so 4 into 46, so that's 2, if I tell x, 2 root 46 by 3, right? So that is the length of this side. Okay, so it's very easy. We just have to extend this these sides to form a new triangle, and if you don't want to extend, then also it's okay that you can directly apply the concept, keeping this in this shape in your mind, or this portion in your mind. Okay, I hope you are getting me. Friends, too many problems based on trapezium we have discussed in this session. In the next session, we'll be taking some more problems based on trapezium. So this topic should be set in your mind once for all. Okay, so revise this session. I'll see you in the next session once again. Bye-bye.